How are we doing? Good evening, everyone. So it's nice to have you back for yet another session. What an awesome time. How was our day? And yeah, happy weekend. Because let me just share my screen and then. Yeah. So today, yeah, if you can hear me clearly and well audible, you can just signify or just drop a comment, or you can use an emoji. Anyone? Yeah, so I guess we can go ahead with the class, right? So today we'll be looking at let's see, proof of stake versus proof of work. So today we'll get to understand what's actually the difference between the two. Why proof of stake? Why not proof of work? And some key themes to why we now have lesser. Initially, we were having big systems, and now we now have lesser systems to run. Which, mind you, I have one here, so I had to shut down one of the nodes we have here so that we could also see that and get to see how it looks like. So node 101, as usual, the fundamentals of running nodes. This is day 3, which is what? Friday. So go into what? Deep dive into what? Consensus, which is either proof of work, proof of stake, delegated proof of stake, and others. So let's get into it. As usual, if I'm moving too fast and you think probably I didn't explain something well, feel free to bring my attention to that and I'll go over it again. Yeah, so let's go into it. So the building, let's look at what we have done previously before we get into today's session. So what have we done? We did blockchain and Ethereum basics, which was the recap for the week. On Monday was what? Blockchain and decentralization. Wednesday, Ethereum's ecosystem, a brief story of it, what actually happened 2013, 2015, and up to date, and the current and progress, and a little bit of the ecosystem too. That was what we looked at on Wednesday. Now it's Friday, so we're going to what? Deep dive into Ethereum consensus mechanism. So let's get started. What is consensus mechanism? So sometimes you might be like, okay, I think previous classes here, I've also made mention of consensus mechanism and also gave examples of what it actually is. So how decentralization network achieves what? Agreement. Because to everything, to every network, imagine we say, okay, this is decentralized, then how do we, it's even way harder to bring people in from different places compared to when we are all together and then there's a single point of entity. That is a little bit more easier. So how do we then bring in decentralization and also come to agreement to, okay, this is what we'll be doing, this is how we'll validate the blockchain, this is how we'll propose a block, this is how would, all that is called what? A consensus mechanism, because we all came to agreement is either proof of work or proof of stake. And then initially we'd go into that, how Ethereum moved from proof of stake and proof of work to proof of stake. Let's look at the definition. Consensus mechanism are rules a network uses to agree on which transactions are valid and which block should be added to the chain. Importance: without consensus, there will be no way to verify transaction. So it's just like without agreement, we would always have conflict. If I'm showing up with my own transaction that has a weird looking hash that I generated from somewhere without using the one that has been set aside, you also show up with your own. So you can now see that there will be a single point of failure because we can now change these things and I can't verify yours because you used a different algorithm. I used a different algorithm. And then we are now trying to bring them together. It won't work. So that is one of the importance. Then key role in maintaining blockchain integrity. Consensus ensures that the blockchain remains consistent and trustworthy, preventing yeah, preventing tampering or what manipulation. So with that agreement now, it's easier for us to, because we all have those hashes and those algorithms and whatever mechanism we have. So we could test that for ourselves. When someone is giving you a transaction, if you are a node operator, imagine, okay, for mathematics too, we also have consensus mechanism. When you're being given um, some mathematical formulas to solve. What you need to do, the consensus mechanism there is what? Board mass. You need to start breaking it down, solve from brackets to um, is it division, multiplication, addition, subtraction. So that flow there is the what mechanism. You can't start from subtractions and try to solve a question that it's probably two open brackets, four close brackets divided by two. Then you are now trying to add them up. It doesn't make sense. So even in the real world, off chain, we also have what? Consensus or mechanism. It's just an agreement, a standard that we all work with. So if I'm to show up with my final answer as two, you also can verify that I got two by applying that same board mass to it. It's the same thing here, which would be used for preventing what? Tampering or manipulation. I hope we are following. I noticed, okay, there are so many note takers here. Okay, yeah, okay. I can see. Please, welcome to the show. So I think I can continue. If you have any question, feel free. Just stop me and then I'll go over it again and we continue. So understanding proof of work. Let's start with proof of work because initially Ethereum started from where? Proof of work. So we can't just jump to proof of stake, and you need to know why we started that way, why we left it, and yeah, understanding proof of work. Now, mining process. Miners use powerful computers to solve cryptographic puzzle. The first miner to solve the puzzle gets to add the next block to the blockchain and receives a reward. Let's break this down. If you have, what they are meant to do here is that there is a set of rules that you would have to generate a random number that starts, that has, initially it was eight zeros in front, it went to 32, now it's currently at 62 or 64 for Bitcoin. Let me just break this down. Imagine I give you a function which is x times y, and then I say, just guess. I'm now giving you y. I always give you y. I now say for the x, you should randomly guess the x value. That when you multiply it with what I give to you as y, you would get a number that has a decimal and two zeros. So for example, now all I need you to do is to generate a number that start with 0.01, point 0. Just make sure that there's a decimal point, and after the decimal point, there's a zero after the decimal point, then any other number, I would accept it. So that's my own rule. So I now give you 2. You would now start guessing, okay, if I have 2, what do I multiply by 2 to give me a number that has 0.0 something? You would now guess, okay, 3. 3 times 2 is 6. That's not possible. So you now guess, okay, 2 times 0.8 would give you, you now see how the logic work. So you keep multiplying, you keep generating. The x is for you to guess. So you keep guessing that number and multiplying it because the algorithm is x times y. I'm giving you y. All I need now is a number that would have a decimal point, and immediately after that decimal point, I need a 0 and then any other number. That is my own criteria. So when I give you 2.5. That's, let me say, yeah, 0.5. You get to multiply it by random values until you get a number that has what? Point zero something. So as soon as you get that, if you are the first, you get rewarded for it. It's the same thing that is happening on the blockchain. So, but what they get is way above X and Y. I'm just giving you an example. So look at our X and Y as SHA-256 because that's the algorithm on Bitcoin. What you put into SHA-256 is the block header, the previous block, the transaction data, and the nonce. So the nonce there is the random number that you would pass, that you keep guessing. So when you guess the nonce to be 13856, and then with the transaction hash and the block header, which is constant, you get that from the previous block or the transactions that are being recorded. If Alice sent Bob 10 USD, that's a transaction. That does not change. So it is constant. That's the Y. So I keep giving you the Y value. So the Y is the transaction hash, the previous block header, and your nonce. No, the nonce is your Y, which you would keep guessing. Then you would have to pass that through the SHA-256. The output you get is a hash. That hash for Bitcoin, you can guess that nonce to be any number, but all I just need is that hash should start with 62 zeros. Then if you are the first that produces that, you win, and then you get rewarded for it. So you can now see how complex it is. You keep trying random numbers so fast so that you can be the first, because there are so many people trying to do that. If I'm to do this now, I say, okay, one Ethereum, one ETH for anybody that gets a number that start with, when I give you a number, you multiply it by your own number, and then all I need is 0.028. I just need, after a decimal, there should be a zero there, and then any other number. You would keep multiplying random values that comes to your head. But because you can't keep up with that, you now have to get a system that is way powerful and that can process transactions in milliseconds. That is why Bitcoin uses sophisticated hardware that performs that mathematical operation in seconds. So one Bitcoin machine can be guessing 1 trillion hashes, 1 billion hashes within seconds. All you just need to do is to get the hash, the transaction which it has been given, then it will now keep guessing that nonce, which is 1256. It will put it into SHA-256. It will guess another and put it into it. It will guess another. So it will keep doing that until it gets. So everybody will keep doing that. That is why you need sophisticated hardware systems, because on your own system itself, it will take you days. And sometimes you can't process more than your CPU can carry. That is why it is what? Proof of work. And that's the whole complexity for using hardwares. You're trying to solve that cryptographic hash, which is generating a random number that starts with 62 zeros. So that's just, I don't know if anybody understand, or if you want me to explain further, please let's make it interactive. If you want me to explain further, I can go back. And I hope you can all see my screen. Yep. So any question for me before moving forward? And I hope that was understood by everyone. Okay, yeah, network security. By solving this puzzle, miners validate transaction and make it computationally expensive to alter the blockchain history, securing the network. Because of that whole hard work and all that, you can't reverse the process. Environmental impact. Proof of work requires a massive amount of electricity, leading to concerns about its environmental sustainability. This is all because you need hardware that consumes a lot of electricity, and those electricity, something has to generate it, and some of them generate a lot of heat. And if you're using probably light or solar or generators, you get to pollute the environment, because the solar systems you would have to change them over time. So you can now see where the whole environmental issue is coming from. And then you use a lot of electricity because they run on GPUs, high-end system. Not just our systems now, probably 65 watts, like the one we have here, which I'll be showing us towards the end, is 65 watts. Just small, a little bit of cooling fan, and that's all. But for Bitcoin mining system, sometimes you need AC and all that stuff to keep it cool. And yeah, sometimes the system, there are cooling systems that uses water. You can pass water through your GPU and all that. It's a whole lot. It's beautiful, but yeah, you can't go into that now. Let's go into the next slide. So this is the visual representation of how Bitcoin mining actually works. This is proof of work. That's why we are using Bitcoin. We are not actually focusing on Bitcoin, but because Ethereum have left that, so we need to use Bitcoin since Bitcoin it's still on proof of work. So transaction creation. Users initiate transaction on the network. First of all, I gave you what the two, which is a transaction coming from a store. You could also check this like someone you going to a shop to get something to buy. That is what a transaction. A user initiated that by coming to your store to get something, right? Transaction pool, pending transaction, wait in the main pool. Sometimes you have gone to a store that you have to wait because of what? Probably crowd, or they were trying to validate something, or something went wrong in the store. And then they decided to like, okay, those coming in to get something, just hold on a bit while they attend to every other thing and then sort the issue. So that is what transaction pool. Mining competition, miners compete to solve cryptographic puzzle, which is that puzzle I gave you the analogy of. If I'm to give you Y, you just guess the X, multiply it, give me a number that start with any number, but I just need to have a decimal and the next number should be a zero there. So you can multiply it by 0.8256. I don't want to know, but I just need you to guess that X, that when you multiply it with your Y, you would give me a value that has a point, zero, and then any number. So for Bitcoin, you take the data, transaction data, previous hash, and some other input with the nonce. The nonce is now the X in our own case. That nonce would now be the random number you would keep changing until you generate a hash that is unique, that starts with 64 zeros. So that is, let me also define a little bit about the transaction pool. So the transaction pool, commonly known as the main pool, which is the memory pool, that's the short word. If you hear probably transaction pool, main pool, memory pool, it's all the same thing. So this is a critical component where unconfirmed transactions are temporarily stored before being included in the block, right? So they just keep them there for more verification subsequently. So in the meme pool, how it works, we have transactions are submitted. When users initiate a transaction, it is broadcasted to the network and received by individual nodes. That's it. That's like a copy of it. I've made an example with that in the previous session. Validation, each node validates the transaction against the protocol rules. So that's how you go about it. Then we have what? Storage in mempool. Once validated, the transaction is placed into the node mempool, awaiting inclusion in the block. So once it has been verified, we now want to permanently write it to the blockchain, because at that point in time, in that verification process, when something is done wrong, probably a bot is trying to intercept or something, the transaction you made can be reverted because it has not been added to the block. So at that point in time, during verification, it can be reverted. Sometimes your gas fee, the miner might reject it. You might decide to manually tamper with your gas fee, and then the miner will be like, hey, who is this? Why are you paying me this low to verify your transaction? I don't want it. And then you might notice your MetaMask load a bit and says transaction fail. It has not yet been added what to the block. So as soon as it gets verified, it is sent what to the main pool to be added what to the block. Then we have propagation. Nodes share their main pool transaction with peers, propagating them throughout what the network. Then the final stage for this transaction pool is the inclusion in the blocks. Miners select transaction from the main pools, typically prioritizing those with higher fees. Like I told you, those with higher fees first come. It is not actually first come first serve. It is higher fee first served. But when the fee is all same, it is hopefully first come first serve. So that's just the transaction pool. You can see what actually happens there. So the transaction pool is where that whole validates and your transaction gets to be included in the blockchain and all that stuff. So that's the main pool. And yeah, let's go into the next. Transition to proof of stake. So this is where Ethereum decided to. We were in proof of work trying to mine all those stuff, use complex hardwares to solve those cryptographic hash and validate and not validate, but to mine. And then here comes what? Proof of stake. This is what? Instead of mining, validators lock up a certain amount of their ETH as what? Stake. This stake act as collateral, incentivizing what? Good behaviors. We have explained staking a bit in the previous session, so you can do well to check that. We have validation, which is what? Validators are selected to propose new block and attest to the validity of others' validators' block. So if you are there as a node operator, you get to also propose a new block. That is, as soon as you have 4 transactions, one person is selected to bundle them up and create that block. And then you also get to verify other people's block. Okay, hey bros, that block you're making, does it have enough? Let's look at it just the way we are building our houses. You'll be like, hey, is there enough cement in that? Did you use enough water, the right amount of sand? So in the blockchain space, that we call it verification. So you're just trying to check that the block others are producing are not corrupted. Probably the transactions are bad and someone is trying to game the blockchain by creating or proposing fake blocks before it is being added to the main blockchain. You can decide to like, hey bros, somebody is doing something here that is wrong. Then the network what penalizes that individual for that benefit. POS consumes what? Not not the POS you actually withdraw cash from. Proof of stake, please. So the POS consumes significantly less energy than proof of work. This cannot be compared. It's way less, and offers potential improvement in scalability. That is for sure. Because now, on Bitcoin, when probably if one of your mining rigs or something gets faulty, that is very expensive to get it fixed and have your systems running back on. So sometimes, yeah, proof of stake saves you all that cost and all that headache for that. So this is the benefit of proof of stake. There's a lot of benefits, a lot. So this is just some of them which I have mentioned here. There's a lot. So as we go further, we'll look at them. So let's visualize what proof of stake on Ethereum. There are other platforms which we'll talk about, but probably not today or not now. So what we're looking at is what? Staking. This is how proof of stake works in Ethereum. First of all, validators lock up 32 ETH as stake. So this validator, you are the individual with your node and your software and all that. You have to lock up 32 ETH. The analogy I gave about trying to get a job whereby they need you to stake certain amount before they give you that job, right? So same thing is being applied here. Validators lock up 32 ETH, which is the minimum. You can stake 64. Validator selection. So validators randomly chosen to propose blocks. So you are randomly chosen, just like the analogy where you get to stake in the shop, right? And then when a customer comes in, if you have 5 people there already working, they might decide that, okay, worker A, you attend to this customer, worker C, attend to this person. Same thing also happens in the blockchain. You get what? To be picked randomly to what? Propose a new block. Then we have what? Attestation. Other validators verify and attest to the blocks. So whatever you have done, if you have been chosen, that does not mean you have the whole powers to yourself. No, there are people behind you. Every other person is watching and looking at you and be like, okay, yeah, let's see, what would you do? Then whatever you do, it would be what? Verified and also checked that the block you created was actually right. So you were actually chosen to create that, but others only verify what you have created. Can you now see how the logic works? Then we have block proposals. Selected validators create new block. Only selected validators. If you have been selected, those that are meant to verify don't create. They only verify what you create. So, but because this happens very fast, you might think everybody is validating, everybody is creating. No, the network picks within seconds. It picks how many people like. So, it's because it's very fast. So you might think everybody is creating it. No, it's one at a time, but it happens very, very fast. Only selected validators get to what? Create new block. Yeah, so this is the whole idea behind, and that is why the system with me here, it actually does something, same thing, where it has not 32 it, mind you, this is on testnet, please disclaimer. 32 it on testnet. Then we get what? To be what? Selected randomly by the system, and others get to attest, and we create what? New block. This is just proof of stake in its simplest form, nothing too complex. This is what you keep doing over and over and over. That's why it's in a cycle. You stake, you get selected, block proposal, or you attest, you stake. The staking is done once, so you don't need to stake again. As long as you're in the system, you are selected, you propose a new block, or you attest, you're selected, you propose. That is what you keep doing on the network. That is proof of stake. So any question before we look at the key differences between proof of stake and proof of work? Any question? If you want me to explain anything or anything, feel free. Any question? So many note-taking AI. Okay, yeah. Oh, you had your hands raised up. Please feel free, speak.
Yeah, good evening.
Yeah, evening. Nice to
Yeah,
have you here.
my name is Uji. This Ethereum staking, for instance, for instance, we are in a bull market, and according to speculations, probably the bear market will soon come. And then, as a validator, maybe I see that Ethereum price will soon go down, and I want to
Mm,
take out my 32 it for the meantime till maybe wait till when the price is very low. I will sell and then buy low and then restake again. I hope. My question now is, if I do that, would that penalize me, or would there maybe like would a system like maybe do I say take me back on the queue, or I don't know how the selection process or how
okay.
the randomization is done, or would there be any form of penalty or something for just coming in and going like that based on
Okay.
the price of the token, the coin rather, Ethereum.
Yeah, I like that. You know, for every business, you must have your plan. Probably you might have planned that, okay, if it gets to maybe 5K per one, you would pull off. And then when it gets back to 2K, you can. So the simple thing is that you remember you staked, right? All you need to do, don't just shut down. In short, you can't have access to your 32 it until you unstake. So when you see that, okay, yeah, at this point in time, I no longer want to continue running the node. I want to have my ETH, use it for something, or just convert it. You just need to what? Unstake the 32 ETH. Because if you leave it there, you can't convert it to USDT or anything. It is there as 32. So for you to leave the system and make use of what you have, you just need to what? Unstake. You get back your 32 ETH, then you use it for whatever you want to use it, or switch it, or get into other businesses. Or sometimes when Bitcoin, if you notice, when Bitcoin or ETH rises, some companies employ a lot of people because why? They can now pay them. But when it drops, they let go of some people. So sometimes they do that. So you can unstake. What you do is what? You unstake, then you convert to probably USDT whole. If it goes down, as you said, you can buy back, you have made your profit, and then you stake back. But mind you, when you unstake, you are no longer a validator. So the rewards for validator would no longer be coming to you. Only the one you have made while you were in the system would be given to you. As soon as you unstake, you have left the system, so you won't get any reward again. And then you can come back, stake again, and you can have multiple systems that have been staked with them 32 each of them. All you need is, would go into that, your validator key. You can have one system having different 32 each with different validator keys and all that. But you can do what you just said. You unstake. When it goes down, you buy it back 32, then you stake back. You would not be penalized if you unstake. But if you don't unstake and you just shut down your node, and you would be penalized, and your ETH would still be going down. So is that understood?
Yeah, yeah, yeah. Thanks.
Okay, cool. So any other question before we move further? So proof of work versus, please, if you have any question, just unmute. Sometimes I don't see it because of the slide. I have to change. So if you have any question, just unmute yourself and speak. So now we'll be going into proof of work. I don't know. Okay, after this slide, I'll just go through the node I have here. I had to shut it down. Then I would show you some of the things like what we talked about, but let's deal with this and then we'll go back to that. So proof of work versus proof of stake. The key difference is what? Validation method. We have mining computational power. Here it is called what? Staking economic what? State. Energy consumption. This is very high. But here it's very low because the system consumes less energy. Hardware requirement. You need specialized mining rigs, just like digging gold. You can't compare digging gold with investing in stocks. Those are two different. You would need tractors, need this, the land. You keep digging until you find gold. After getting gold, you don't just see gold in its pure form. No, you would have to go and start taking it through another process, refining, and same thing here. Bitcoin, that is what it does. So you have to keep the hardware, the requirements, then you now start mining. When you get that, fine and good. Bitcoin is already refined. So that's the difference with digging or looking for gold. So we have what? Specialized mining rigs, standard computers, and what? Your staked ETH. This is it. For some of you, might be like, 32 ETH is high for individuals. Actually, it is high. This is where we all smiled and we are all happy that every other person can now run that. But 32 ETH, that's much. When you do that, that's about 80k USD. Like, but don't worry, there are solutions where you don't need up to that to be able to participate in the network. So this state, it was kind of an issue for individuals, but it has been solved. So you don't need that much it to be able to be a validator. It has been reduced. Then we have security model, computational what? Computational power, then we have economic state and validators behavior. So this is based on, the security here is based on your computational power, your system, the capacity and how well it's being tested in the network. The difficulty of solving that hash makes it, gives it that whole security, how would I put it, security touch. Yeah. Then for economic stake and validators behavior, so this is based off your own behavior. If you act good, it will be secured. If you act bad, it would still be secured, but you would be at loss. So that is the security model here. And the model is just a way to be able to make it more secure. So if you act bad, you get punished. So you would not want to act bad. You keep acting good because first of all, you don't get punished, you get rewarded. So gives you that gives you that edge that okay, I want to act good. I would keep acting good. So that's the security model they are applying here. Let's move into the next slide. So the merge, Ethereum shifts to what? Proof of stake. How did it happen and why? We were at proof of work. You need a lot of sophisticated systems to run your own what node. But now the merge was an event where Ethereum transitioned from proof of work to proof of stake, a pivot moment in its history. Like it actually shifted the whole industry. It became faster, secured, consumes less energy, and the world loves its what natural what environment. So anything that destroys the natural environment or the ecosystem is not good. So but Ethereum now shifted from proof of work, which was actually significantly impacting the natural should I say, ecosystem that we have. But now with proof of stake, it has reduced that drastically, which is now eco-friendly. You can have your nodes run for a long time without having all those issues with the natural environment where you stay. Yep. Then we have motivation. Ethereum transition primarily to address energy consumption concerns and improve scalability. These energy concerns is where the natural what's the word? Let me say the natural impact we have on those hardwares. Why it is eco-friendly good. It is because of this less consumption makes your environment more friendly and well to live in. Then we have key benefits. This transition brought about reduced energy usage, enhanced security, and potential for greater what scalability. And that is what we are seeing now. If this was not possible, I tell you, I can't run any node here. It would be humanly impossible. It would be possible, but probably I would need to have more than to set just to get one system, one mining rig. It cost a lot. So, but this now made it what? For greater what? Scalability. So many people now have access to it. You can also run your own if you have like an enterprise where you are rate limited. Currently, we are running base node. It would soon sync. So all you just need is our RPC. You can just plug to it and then deploy your smart contract. So you do things directly. You don't need to pay for RPC endpoints, Alchemy, Infura. No, you can have your own for your business and then just submit transaction to your own node. You're not paying anybody. And then the gas fee still also goes to what? You, because you are submitting it to your own node. So you can now see what this has done. And this also opened the door for individuals to now have platforms like RPC providers. You can have these nodes in different locations, join them up, and then before you know, you have something like Alchemy. Imagine we have an inferior, probably like an academy or inferior world for just Africans. That's mind blowing. All because of what? The the shift from proof of work to proof of stake. So those are some of the key benefits we have enjoyed. So Ethereum future upgrade. So let me just run you through these terms and how it happened. So the merge transitioned Ethereum from proof of work to proof of stake. Don't forget that is what the consensus what mechanism. Then the surge introduced what shredding and layer 2 rollups to massively scale transaction throughput, aiming to achieve up to 100,000 transactions per second. On Bitcoin, we have it's 15 minutes, right? But currently now on base is so fast. Why? Because we now have layer tools, they are roll-ups. The example we made, they bundle up this transaction, split the fee between everybody, and then submit the proof of the transaction that, okay, yeah, Mr. A and B actually did this transaction. We are just helping them bring it for you to the blockchain. So Mr. A don't need to pay his own gas fee. Mr. B, no, they all bundled it up, roll all the transaction, and then submit that to the blockchain. Then we have the Veg, implement vehicle trees to optimize data storage, reducing node size. And I'm telling you, this actually helped a lot. I would show you why, because initially you needed huge amount of storage. Huge amount of storage increases the size of your what system, and also increases the use of electricity because your board increases, which uses more. You can now see where the trend is now following. Anything that increases the size of the system increases the usage of the electricity because the board would have to be what bigger than the whole system. Yeah. Then we have the purge. This streamlines Ethereum by eliminating unnecessary historical data and technical debt, reducing node storage requirements, and simplifying the protocol. So with this, you don't need to keep unnecessary transaction. With this, it was now possible for us to be able to sync our node. We would go into all these terms, syncing and connecting. You don't need to start fetching or copying. You know, I told you that all the blockchain have a copy of the transaction, right? So you don't need to start copying the first transaction. You don't need to start keeping track of it on your own node. Your node does not need that. Currently, where we are, your node can just pick up from that state and then start copying transactions that are being made from that day moving forward. There's no need for it to go back and copy just so that it would keep it. No, there's no need. It has been what solved. Then we have the plunge, which what encompasses this what this aspect does. This one, after all these processes, there were minor upgrades that needed to be done and some minor fixes to make everything work better and some few tweaks. So this was where it was done. Probably they forgot to add some salt to it and then discovered that they needed a little bit of groundnut oil into the soup. So it was in what the plunge. They actually added all those things and gave it what a better what dish. So that's how it works. So the merge, the surge, the veg, these are all. But the main one you should just be concerned about is the merge, where everything shifted from proof of work to proof of stake. Yeah. Then we have the benefits, which are what energy what reduction, current usage, and carbon impact. This is it. This is why it is now what eco-friendly and we now enjoy what we enjoy now. So drastic reduction in energy consumption compared to proof of work, estimated global Ethereum network consumption after proof of work. So this is the whole. I'm telling you, only one Bitcoin or probably maybe 5, 6, 7 Bitcoin rigs can consume this. But imagine estimated global Ethereum network consumption. That is insanely small. The reduced energy consumption translates to a lower carbon footprint, making Ethereum more environmentally friendly. POS makes Ethereum more sustainable in the long run, addressing concern about environmental impact of blockchain technology. Whatever you are innovating, make sure that it does not affect the environment that much. Try as much as possible to reduce that, and which is what Ethereum has what solved. So let me just show you. Let's get into some fun parts. If you have any question, please feel free to ask. Let's go into some fun parts. Let me bring in, I'm moving my keyboard so we could see the node I have here. Let me turn on the lights and let's have some fun here. So please, if you have any question, feel free to ask. Yep, and this is my device. So can you see my, I hope you can see what I'm
Yeah.
doing now. Hello, can you hear me?
Yes, yes, we can hear you, we can see.
Okay, okay, good. So this is one of the node we have here currently. This was actually running, but I just turned that off because of the workshop. So this is it. Something like this runs the blockchain. So, but if you have a system without the required software and the configuration and all that, it is not yet a node. But I'm just telling you that any system you have, if it's a desktop, there are requirements you need to set for it to be able to function as a node. So you can see it is just a Lenovo, and let's get into it. So this is it. You can also build this yourself. As you can see, this has been running for a long time. So I just had to turn it off just for this class. This is where initially I had the SSD, but for nodes there are requirements which we'll look into next week. So we run on SSD, not HDD. So I took out the HDD, which is a bit bigger here, as you can see, reducing what the size of the node. And this is our cooling fan. So this is just your minor system, your computer, and this is the Wi-Fi connector I'm actually using. For some of them, I'm using an internet cable connection, which I also have here. But all the nodes, I have a setup where they are all stacked up. So I can't have them in my room. I need to sleep. Yeah, but so let's now look for, yep, so this is it. This is the RAM. This is just 16 gig, 8 each, and you're good to go. You can see how cheap this is now. It has been made for us to be able to run these nodes because why? These are now affordable compared to proof of work. I hope you can still see my screen, right? So this is my SSD here. This is 2 terabytes SSD and currently running. I've not maxed it out. I still have some space on this. So you can also build this yourself. You buy this individually, you just plug them in, plug them in. You get this system. If you already have the system, you can just buy an SSD, get the required specification, your RAMs, and all you need is a stable internet connection, either using your dongle here or you use your network cable. So I also have my network cable here, which I could bring into the picture. So this is one of my, sometimes I might just decide to run on cable connection, and then you could just slot this in. So next week also would also be showing you the whole setup. And yeah, it's fun running all these things. And this is a node because this is currently running the softwares that actually makes it a node. I now validate proposed block and also make some reward from this. But mind you, this is not 32-it. Disclaimer. This is not 32-it. We would go into that and how it was made possible to run on something way lower compared to 32-it. So this is just the block. This is a node now. And if you have any question, feel free to ask before I take it away and then we continue with the session.
Yeah, please, I just want to ask, this node that you are holding now, if someone want to get it, is it available within our country here, or is it something that we
Ye-
ordered?
yes, we built this ourselves. Like it's not, it's now way easier. We built it ourselves. We knew the requirements for the hardware, for the for the SSD, the requirement, we know what the exact one to get because it's not all SSD that you use. And sometimes the board, this is i5 8th gen. So sometimes you need to get this specification. You can build it yourself. If you get a system that has all those things, fine and good. If you don't, you can either upgrade some parts or change some parts. And yeah, we did this all ourselves. And there are nodes, there are much, so many in Lagos. Yeah, so you can get them here. We can continue. Any other question before we go further? So next week we'll be going into the detailed part of the requirements. Would probably dismantle one of the node. If I'm to have this back on, and then okay, let me also show you this. So this is where you can also view what is actually happening. I turned this node off. I could not find the hash to where I kept this node. You would actually see the active state turned off. It would be on red. And what you can see here is what? Miss. So I was being called to propose a block, but because this node was off, for all of them, not this one. These ones are the other nodes that are still running currently. So for others, what like for this one now, what you would actually see is all here would be red. It would just be red. It would just be miss because they called me to like, hey, attend to this transaction, create this block, and I was offline. So to the other question that was asked, if I'm to do this now, all I just need to do is to unstake what I've staked so that I could leave the system and the system would stop calling me, thereby I would not be penalized. But now I just turned off my system. You would keep seeing this negative, and this negative means I'm meant to be given this if I had been in attendance. But because I'm now absent, instead of giving to me, they take from me. So the 32 ETH you have staked, rather than giving it to you, what they take it, they don't take the whole 32 ETH, they just take a portion of it. So when they call you, Mr. Jewel, you're not there, they just take out from what you have staked. But when you are present, which is this, you what get the reward for doing that. So that's just what the blockchain does. And like we saw in the diagram, that cycle keeps going over and over and over again. So any question? So let's look at POS benefits, enhanced security, economic security, stronger economic incentives for honest what behaviors, attack resistance, increased resistance to 51% attack. For you to be able to do this, you need to be way richer than Elon Musk. Just know that. We'll explain this next week. Slashing penalties, like you can see the red mark there. Oh, I've turned that. Okay, I have one here. This is another one. This is a different one. So this is a penalty. This is the slashing penalty. When you hear slashing, that does not mean it would be divided into two. No, what you're meant to be given for that day would be taken from you. So this negative is what a penalty for missing that. And I was actually active. Probably the node network or it kind of responded slow, and someone was what now called to do that. I was now penalized. But every other thing, as you can see it's running smooth. For this, I was offline for like 2 days. I was having issue with it. So as you can see, it was down and I was penalized for that. So that is what it means by what slashing penalty, economic penalties for malicious behavior. Mine, I was just absent. And sometimes that absence means I'm trying to like manipulate the data I've downloaded. So I get punished for that. In POS, an attacker will need to control a significant portion of the staked ETH, making a 51% attack much more costly and difficult. Very, very expensive. Validators who act dishonestly can have their staked ETH slashed, not divided into two. Don't mind the term, but you would keep hearing slash slash. Providing a strong economic this incentive, these factors contribute to more secure. And so for me not to get slashed, I need to what? Do the right thing. I need to have data. I need to be online. I need to be active. As soon as there's an error, I attend to that and fix the node in order not to get what? Slashed. So that is what it does. Validators, the backbone of what? Proof of stake. Definition: validators are network participants who stake ETH and are responsible for proposing and validating blocks, just like I am and just like you're about to be too. Probably, hopefully, at the end of this session, the whole workshop, you would be able to set up your own and would be able to give out some too and have them distributed all over Nigeria. Selection: validators are selected based on their stake and are rewarded with it for their participation. Let me bring up that diagram one more time. So this is it. I received, okay, this is pending, this is pending. This is, as you can see, attested. Others are what? Confirming that, yeah, what I did was actually correct. So I get rewarded for this. This is my reward each time I'm being called. So others are attesting. As soon as they are done attesting, it will change. I need one that has been, okay, attested. Yes. So attested, it has been what? Confirmed. Let's go to the first attested. So this is still pending, still trying to validate, and yeah, attested. So this is what this part is saying. I got selected to propose a block, and that's the reward. Network rule: validators plays a crucial role in maintaining the network's stability and what? Security. So I can't act bad, thereby what? Maintaining the network. And I can't bring someone to act bad because I would be what? Penalized. Security. So if you have any question, don't forget, unmute your mic and ask. Validator's responsibility, excuse me, and core function. Block proposal. Like what you saw there, I was actually proposing what? A block. Validators are responsible for creating new blocks and verifying transaction within them. Remember, each block has what? A series of what? Transaction. Block attestation. Validators vote on the validity of blocks proposed by other validators, ensuring consensus. As you can see here, it says what? Excuse me, attested. So people have voted that, yeah, okay, the block I produced was actually right and correct. Slashing, there's no slashing there. So I wanted to show you that. So block attestation, validators vote, that was fine. Network participation, validators must remain online and actively participate in the network to fulfill their responsibility. Currently, this node that is off is being penalized now currently, but I could not find where I kept the hash. I would have actually given it to you. You would see it, it's turned off. And every other transaction, everything you saw there on the others were green. For this one that I turned off, it would be all red, and it would be taken from the 30, that's the 32 ETH that was there. So if I've made maybe 32 ETH, I've been there for like a long time, maybe, and I've gotten 33 ETH, the reward, the penalty would be taken from the whole amount, which is 33, until it goes below 32, until it keeps going, keeps going. So if you go offline for like 2, 3, 4, 5 years, you might end up coming back and seeing maybe just 16 ETH. They would keep taking it until you come back to the network. So you need to be online fully. Chain.
Hello, sir. Hello, sir. Quick
Yeah,
question,
yeah.
sir. So,
Okay.
I just want to ask a question based on what you just said. Now, let's assume that I stake with 32 bits ETH, and
Yeah.
I've already made some gain with it. Let me just say like 33 now. So maybe
Yes.
something now happened. I was unable to be online. So they now removing, and it's not at the end of the day. Before I came back online, is now less than 32. Can I still
Yes.
continue?
Yes. You would still continue. I think I have. Oh, I don't. As long as you have not left, you are still there. you can still continue. But when you live with that, let me say you decided to leave the system with let me say 31 ETH. When coming back, you would have to top up to join back. Do you understand? I think this one for this day, how do I revert back to this particular day? For this particular days, I was below the amount that was staked. But as soon as I fixed the issue and had the system back on, this turned active. And then currently you can see it is now above 1. For this one, you need just 1. So, but I was offline and I went below 1. So, but then after fixing it, it kept running for days. I'm now above 1. And this, the minimum is 1, just like that. So you can still continue as long as you just come back online. But if you unstake below that 32 ETH, when coming back, you must complete it to be 32 ETH for you to be able to enter.
All right, sir.
Yeah, so any other question? So chain synchronization, maintaining an up-to-date copy of the blockchain. So currently, as you can see here, what is happening as this is happening, oh, I can't show that. Okay, subsequent class I'll show you how it's actually copying, and the whole software is here. I just SSH and we'll all do that. It's fun and interesting, and yeah, you would actually love it. So what I'm doing now, what this is doing, after validating, I'm copying the blockchain. That is why you need a required amount of what? Space, because you'll be copying the transaction. You'll be having a copy. So everybody that tested has a copy. You have a copy. So that is it. So this is the chain synchronization. You're copying what? Every transaction that is being created. Then we have slashing, ensuring validator what? Accountability. What is slashing? Slashing is the process of penalizing validators by removing a portion of their staked ETH for malicious negligence. Slashable offenses: proposing multiple blocks for the same slot, submitting contradictory attestation, attempting to rewrite history, prolonged inactivity or downtime. That was what happened to me here. I think, oh, it's gone. Let me see if I could find that. Yes. So probably prolonged inactivity. This was what happened here. Or downtime. Probably just, I don't know. So this is it here. If I try to propose multiple blocks so that I could gain more, because if I propose multiple blocks at the same time and it gets approved, which is not possible, but assuming it get approved, this would be multiplied by 2. So I'll get double the fee. And where is it coming from? So you can now see that somebody would have to lose. So you are now cheating what? The system. Or because I am now selected, I am meant to propose one block at a time. Because I am now selected, I am not yet done proposing my own block. I am now looking at other people's own and trying to like take it and propose it so that I could get double fee. That is what it means. You'll be what? Penalized. Slashing ensures that validators are incentivized to act honestly and maintain the network integrity. It creates a strong economic disincentive against attack or malicious behavior, strengthening the overall security. So we all know what will happen if we game the system. Thereby, none of us would want to game the system, increasing what? Security. That is it. Then we have what? Proof of stake security, mitigating risks. 51% attack requires controlling majority of the staked ETH, which is significantly more expensive and difficult than controlling mining power in Pew. What this is saying is that for me to be able to like game the system, because what happens in the blockchain is majority. When everybody attests that, oh, your block is correct, it get added. If everybody says it is wrong, you'll be penalized for doing that. So that is how it works. So for you to be able to do that, you need to have 51%, like you need to be in control of you need to have 51% of the staked ETH in your control, and you are a validator. So imagine how many ETH do we have? How many are staked? Get 51% of that. Do you think an individual would want to do that. And as soon as there's a slight mistake, forget it, your money is gone. So who would want to risk that? Where it is almost, it's possible, but the probability of that happening is almost insignificant. Economic disincentives, slashing, and the potential loss of state it act as a strong economic what deterrent against what attack or malicious actions. Sorry, let me just get. I have my bottle of water here, so just give me a minute. Yeah, I'm back. I feel refreshed. So we now have strong economic. Also, same thing happens to me. As soon as I check this, sometimes I check it after 2 to 3 days. Probably something might have happened. The solar probably went off and there was no light, or something might happen, and then this is off. If I'm not aware, this would keep reading negative until. So for me not to be at loss, I have to game up, learn, fix any error, and then. So this is what it's actually saying. It actually prevents what? Attack. Enhanced security, which is overall POS provides a more secure and resilient network compared to proof of work. There are more people on proof of stake, hence more security, especially against attacks that exploit computational what? Power. Distributed validator technology further enhances security by distributing validator keys across multiple operators. There is no single entity that has all the validator key. I have my own now. You have your own. You have your own. So probably maybe one person lost or was attacked his server, and then one of his key got leaked. Only that 32 it would be missing, would be stolen. Not everybody's own, because we all have our own what, validator key that controls that 32 it. Next, I think with this we have come to the end of it, and yeah, let's just discuss, and if you have any question, feel free to ask. And so let's discuss. If you want me to go over any other section, feel free, and I would happily do that. Then now looking ahead, what do we have for week 2? We have Ethereum, which is node setup. As you can see, hardware requirement, understanding the requirement for what setting up a node, because there are specifications it must meet, but the specification are not that much. So that is why any system can run that. Software requirement, learning about necessary software. There are so many softwares that can be used for node operation. So many. It Pillar, it Docker, it currently at Node Bridge, we are also doing something. So many that you can just, plug and play, and you have your node running. Life has been made easy. So why stress? So Ethereum client, introduction to what? Ethereum client and staking concept. These Ethereum clients are also the software. We have get threads, Nimbus, and all that. You would go into all those execution and fun parts where you get to see these blocks, and you get to see it that this is not rocket science. When you create a transaction, we could also query it, and then you could see that we could also send transaction without MetaMask. All you just need to do is to have your node, your RPC, which would have ours here, and then we just send the transaction directly to our own blockchain with our private key without any MetaMask. Is just an interface, a UI. Any wallet you see is just a UI. When you have your private key, you can interact with any blockchain without those tools. So we'll also go into that, and then you get to see how interesting that works. I think we have come to the end of it, and yeah, so we'll be dropping some courses and resources for you to check through and understand what we are actually doing. So if you have any question, feel free.
Yeah. Hello, sir. Can you hear me?
Yes, I can hear you.
So, thank you for the class. It's actually interesting. So my question is, based on the hours to be spending on the running the node. So it's a continuous stuff. So I wanted to
Yes.
ask, what will happen? Maybe you wanted to take a nap, or you cannot be staying awake from morning to all the time. So the little period that you just want to rest, and maybe they cut. Is there a way of knowing a period when you will be called?
Okay, for that, right? Like currently me, you only just check it once in a while to be sure that maybe the system did not go off or there was no error. It is not like you will be the one to accept it. The system does that. You just need to set up the software, the hardware, and this. Okay, let me show you this. Currently, we have been here, and first let's come here. So this is it. I'm not the one being selecting. The system does that. All those software that would be showing you, and that's why next week, don't miss next week, would show you the softwares do that for you. So I don't physically do that. All I just do is I make sure that the system is on 24 hours. I go out, I travel to places. I like traveling. So I leave it here. All I just do, I just SSH from anywhere, check how it's doing fine. If not for this workshop, I've not checked this for like, as long as it's running, you just let it run. You are not obligated to keep checking it or do anything to it. As long as it is set up, you just leave it. And we would also have system that in case it goes down, it can just send you an email. That's also something we are working towards. So you don't need to be checking it. The system does all that. All what I was saying is just for you to get a better understanding of how it works. So currently, I'm being called for this. The system is actually doing the necessary stuff. Others would get to validate it and then it would show up here. So this is the number 886. You would see it down here with the price, the fee that came with that block. So that is how it works. Do you understand?
All right, thank you, sir.
Yeah. Any other question? Do we have any question before we call it a day? Going? I think we can't see this here. Probably I would have loved for us to see this. Hopefully it moves down. Let me just refresh this and let's see if it would move. And yes, so you can now see 886. You can now see the reward. Why? Because it has been attested. So this is also, it happens very fast. So you might think I'm the only one that the system keeps calling. No, it's calling a lot, millions of other people on the network. As you can see, there are about this is 339,000, which is 64%. So we are about almost a million with our own nodes. But as you can see, I'm having transaction almost every seconds. It's because there's a lot of transaction going on, millions of transaction, and we need more people on the network to make it more decentralized. So currently, I'm not the only one being called. It's happening differently as the transaction shows up. So yeah, I think we have come to the end of today's session. Please, next week we'll be getting our hands into it. And also, one hint, next week we'll be setting up some servers here and giving you remote access to them so that you could also follow along for some of the workshop. You could also try them out, have a feel of it, practice them, and then before you get your own personal node. So we'll set up some for you here and would give the login details to you. All would be hands-on. And yeah, we have been talking. Next week we'll go into the main business for the whole session. So it's nice having you once again. Thank you very much for coming. I see one of my bosses here. Thank you, sir, for coming. It's an honor having you here. And yeah, do have a wonderful weekend. Oh, the weekend has started. So enjoy the Saturday and Sunday. So bye for
Thank
now. See you on Monday. For those fasting, please, more grace and wishing you a blissful celebration.